relative to the first problem, if we have masses M1 and M2 suspended over a pulley, I've seen people wanting to do the sum of the y forces on this problem. Now, the problem with doing the sum of the y forces is you really don't have two-dimensional motion with this system, although a lot of what goes on is in 2 dimensions. The motion is essentially just in 1 dimension. Let's see what I mean by that. Okay, first place, you can't use, if you're going to use the y-axis as your direction, okay, either up is going to be positive or down is going to be positive. Well, it doesn't make any sense to choose either of those. If you choose up as positive, then if mass M1 is descending, is the system moving up or down? Well, if mass M1 is descending, mass M2 is ascending. They're moving in opposite directions as far as the vertical position of different parts of the system is concerned. So you can't say up or down is positive. Now, you could technically say that, okay, we're just going to measure the position of mass M1, although the system is going to consist of masses M1 and M2. Well, you still wouldn't add the y forces because the force of gravity on mass M2 acts on mass M1 in this direction, okay? So the force the force of gravity on mass M2 is going to tend to raise M1. It's not going to be a downward force. You can't think of it as a downward force if it's raising M1. So to alleviate all that confusion, we choose 2 directions of motion to be the clockwise direction and the counterclockwise direction. Now, we're going to then, where do I have it? The positive direction. Okay, we're going to declare that the positive direction is counterclockwise. Now, you could make the opposite choice. You could choose clockwise to be the positive direction. Counterclockwise is kind of the default direction for positive motion. The reason being, if you have a moment arm in this direction, and of course we're talking about torques essentially. So if I have this thing and I'm going to rotate it about an axis right here, okay, so it's going to rotate like this. If the x and y axes are in their traditional configurations with the x-axis this way and the y-axis this way, a positive moment arm, which means a positive arm from the axis to a positive vector from the axis to the point of application of the force, or to the point where the line of force crosses the positive x-axis. And we'll sort that out later. You don't really have to understand this. I'm just giving you a preview that explains why we choose counterclockwise to be positive. So a positive moment arm here multiplied by a positive force in this direction is going to rotate the system this way. And this vector is positive, and this vector is positive because this vector is in the positive x direction, this one in the positive y direction. So a positive x direction here, positive y direction here is going to give us a positive rotation, and in that case we see that the positive rotation would be counterclockwise. Now, you're not obligated to use that choice, and all of that isn't particularly relevant at this point to the analysis of this system, but it will be. Okay. And another way of looking at the same thing, incidentally, is if your moment arm is in this direction and your force is in this direction, then when you do the cross product, moment arm crossed with force, you get this direction. Okay? Well, if this is your x-axis, let's say, and this is your z-axis, this is your positive y-axis. So that a positive moment arm and a positive force is going to give you a positive torque, okay? A positive cross product. Again, more on that later. But those are 2 good directions. Why the positive direction is counterclockwise as a default. So I'm going to choose the default. Now, in this case, what's the net force on this system? Well, mass M1 experiences a gravitational force that pulls it down this way. So at M1G, this force, that's a vector, of course, but M1G tends to accelerate the system in what we regard as the negative direction, because that would be counterclockwise. And M2G will tend to accelerate the system in the clockwise direction, which is the positive. So our net force is M2G minus M1G. Now I put an arrow over this to indicate that it's a vector, but it's a vector in one dimension, where the only specification you need for direction is whether it's positive or negative. So is it positive? Is it negative? Okay, this one's positive, this one negative. So we have our net force. Now that means that M1 plus M2 times your acceleration vector is going to be M2G minus M1G, and shouldn't have those arrows. Now the acceleration is a vector because it's going to be positive or negative depending on whether this side is positive or negative. So the acceleration, and I'll drop the arrow over the acceleration, we see that the result could be positive or negative depending on whether M1 or M2 is greater. We solve this equation very easily by dividing both sides by M1 plus M2, and we get what you see here, M2 minus M1, factoring out the G, over M1 plus M2, and all that multiplied by G. Now there are a couple of things that we want to think about here. The first thing I want to mention is that this isn't a formula to memorize. Although it's a very simple formula, very easy to get your signs wrong or mix up something if you just think in terms of the formula. What you have is a very simple picture, two masses hanging from a pulley, that you can easily analyze. We can find the net force and we can divide that by the mass that's being accelerated, and both masses are being accelerated, so we have to accelerate all this mass. We can't accelerate one object without the other. So we start with the picture and we know that we can get to here, and we kind of remember maybe what this should be. Even you could memorize this, but if you don't, check it out by running through this fairly simple process that you should get used to. You're not going to be prepared when somebody throws a monkey wrench into the system. Throwing an extra force in here someplace, throwing some friction in here. How do you deal with it? How do you modify this? Well, it's not necessarily really obvious how this should be modified. What is obvious is how the net force should be modified, and then, of course, divided by the total mass to get the acceleration. So you modify things back here, not here. This is not a good starting point for problems of this nature. It's kind of a checkpoint, but it's not a good starting point. So again, I'm urging you to be good engineers who don't just start with a meaningless formula, but start with the meaning and derive your results, okay? Now, the rest of the solution to the question is asked. Well, the question says, okay, one of these masses is 10 kilograms, and the acceleration of the system has a magnitude of 0.4 meters per second squared. So what's M2? Just plug this information in. Let's let M1 be 10 kilograms. It doesn't matter if we use M1 or M2, but we make our choice. And then we get that G times M1 minus 10 kilograms over M2 plus 10 kilograms equals 0.4 meters per second squared. And there's an absolute value here because we're just saying the magnitude of the acceleration is 4 meters per second squared. To solve this equation, well, first of all, we'll divide both sides by G, and we'll note that 0.4 meters per second squared divided by G is just 0.04. As you can easily verify, and you can get more accurate than that. You can make this like 0.041, which would be a little more accurate. But for purposes of illustration, that's what we're going to use. So the absolute value here will equal 0.04. Now, if the absolute value of something equals 0.04, then that something could equal 0.04, or could also equal negative 0.04. So that this absolute value equation splits into two equations where you don't have the absolute value anymore, and you can solve each for M2, and you're going to get two different results. Now, this whole thing about solving an absolute value equality is something that people are a little fuzzy on. Okay, that's an Algebra 2 topic, which again gets repeated in algebra and gets experienced, or at least should, throughout subsequent courses from time to time. Something you should keep in mind, how to solve an absolute value equation or an absolute value inequality for that matter. So review that a little bit if necessary.